So this is perhaps new to some of you, but really it should be covered. Boolean logic should be covered somewhere in the past algebra course or something. Open. Okay, so we are going to go through basically what are Boolean operators or logical operators and truth table. Pay attention to truth tables. You have to memorize the information there, etc. We'll come to all these. Okay, Boolean data type. Let me just tell you a little bit about Boolean first and show you a small program. The smallest amount of storage in a computer is a bit, binary digit, and it can have the value of 0 or 1 because these are binary computers, right? So there's a type called Boolean in most languages, computer languages, and you can assign values like true or false to them, nothing else. Okay? You can't even assign 0 or 1 because that would be a number. Some languages allow you that, but most do not. So let me write a very tiny program, unless it's already there under code samples, called Boolean. Okay, bool. I have to start idle. Yeah, it opens up in 2.7, unfortunately. So I don't like to use 2.7, but it's there. So to avoid that, I have to use this. Okay, let me show you interactive mode first. True and false should be false, right? So you can test things out right away in idle mode. You don't even have to write print or anything. Please note if I say TRUE lowercase, that's an error. This T should be capital, okay, for Boolean values. Now let me open up the old file from the Y drive. I don't even know what it has, but okay, done is an ordinary variable, right? All lowercase. And false, true, false, etc. show up in orange. So I'm assigning it a value false here. Printing out the type of done, so that should say something about either logical or Boolean, right? And I'm printing out the value of done. Not negates the value in front of it. It's a unary operator, so it changes, it does not change the value of done. The expression results in true, the value true, right? Done is still false. Continue one is assigned false. So you can do Boolean algebra with ands, ors, and nots. They're all lowercase in Python. In other languages, they might be different. Visual logic, for instance, they're different. You have to read the documentation and check what they are supposed to be. So here we have both or and not. So the not will be done first, right? Just like unary minus is done first. And then the or. If you have all three, we'll come to that. Which one has higher priority? To make it clearer, you would put parentheses around this, but they're not needed. They're assumed by Python. So let's just run this. What do we predict as output? False for this, right? And the type should be Boolean. True for this expression. Now done is false, so and of anything false is false. Done is still false. Or, now if the rest of it turns out to be true, the expression, the whole expression will be true. Okay? We'll come to the truth table in a few minutes, but let's just run this and make sure. So class bool says that it's a Boolean operator, but I mean Boolean variable. Let me just align this. Okay. Not done was true. Done and continue 1. Now, why didn't I use continue? Because continue is a reserved word in Python, etc. So, do you have any questions on this basic, simple example? All right, let's just run the other one also. File, open, bool1. I don't even know what it contains. Okay, this demonstrates that x, just arbitrary variable, can be a string first, so it will print type str and the value of the string. Then you can assign it a number. From that point on, it's a number, numeric variable, until you change it. If you change it to a Boolean value, that will be bool, right? And y is just another variable. So we are trying to evaluate this small expression here. And it's worth doing this to see if everything matches. Okay, this should be still lower. So first, x is a string, right? And it prints out the value of x. Then x is an integer. Prints out the value of integer x. Then it's Boolean, and the value is true, right? The value of x and y, and the type of x is still bool. X and y is false, because any one of them being false makes the value false for the whole expression. Okay? So with these two examples in mind, let's go back to the PowerPoint. Now, very quickly, in this, had I assigned 1 or 0, that's not the same in meaning. Okay, in Python, 0 and 1 are numbers, and Boolean values are true, false. In C, C++, etc., there is a confusion, and there is some confusion about that. Okay, so we will discard this 0 or 1. Don't worry about it at all. But it's stored as 0 or 1, right? Inside the memory, it's not stored as T, R, U, E or anything like that. It's stored as the bit value 0 or 1. 0 for false and 1 for true. Now, these are 6 operators, relational operators. They're called relational because they're used for comparisons. Now, they're all binary. You have to have something to the left of each one and to the right. And most of the time you use numbers on either side, right? Each side. You cannot compare a string to a number or anything. Or both sides can be strings, or both can be Boolean. Now it doesn't really make sense to use these for Boolean. Okay? So we'll just use these 6 operators only for numbers or strings. No combination of those. And of course this ordinarily means greater than, etc. This is greater than equal to. Now, of course, on the keyboard, you have to use 2 symbols because this keyboard doesn't have. So this is the symbol in the book or somewhere, but we'll be using this frequently. 2 separate symbols, greater than equal. And similarly for less than equal, you'll be using 2 symbols. Just like not equal is this, and equal is equal in most languages nowadays. Okay? Very rarely. Why is that? Because just one equal is for assignment, right? Assignment statement. So to distinguish between the two, make it easier for the compiler, etc. Compiler is a program which translates from higher level language to machine language. It makes it much easier for the compiler. Any questions on this table? Of course, there are some examples coming up.
So we do have to use equal equal or no?
Yes.
Okay.
In Python, in pseudocode, it doesn't really matter. In pseudocode, because it's English lines, you say x gets 5 equals 3, for example. And you're comparing these two for equality. Or you can use equal equal, but that's too formal and related to languages, right? Pseudocode is independent of languages, and I'll come to that when we discuss homework 3 briefly. Okay? Any other questions? All right, let's go on to the next slide. So, suppose we had two ordinary statements before we come to an expression like this. Is this right side clear? Clearly, 10 is greater than 5, right? Is true, and this false, etc. So just check this out. Let's discuss the last two. This is obviously false because they're not equal. But this not being equal to y is true, right? Because x is not equal to y in this case. If x and y were both 10, then this would be false. Okay? Any questions on that? There are plenty of exercises at the end of the chapter. Please try some of those out. You can actually, once again in idle, you can test some of these ideas out if you're confused. Okay, we don't want to write new program, but go to this shell. And Python allows you to do statement by statement to test things out. For example, x equals 10, y equals 5. It remembers x and y now. If you want, you can just say print the value of x, which is 10, right? You don't even have to say print. Now you can say, is x greater than y? And it prints true or false. Okay? Don't ask me why it's in blue, because in the other mode, when you write the expression, it's orange. So there's a little bit of confusion, but that doesn't really matter here, does it? Okay. So do you have any questions on this slide? All right, let's go on to the next one. So far, we've discussed, well, we are coming to and or not in a few minutes, but for arithmetic operations, this point upwards, exponentiation is higher priority than unary minus and so on. These are the same priority left to right, if you remember, and these are right to left. These are left to right. Relational operators, we are going to assume, at least in pseudocode, we can't be sure about other languages like Python, and Visual Logic may have its own rules. Therefore, we will not make this assumption that this is higher priority than this when we come to programming. In pseudocode, you can make that assumption, okay? Because that's what we have specified here. And these are also left to right, left to right. This is the lowest priority, that's the highest priority. Okay, but what are we missing? And or not, and the assignment statement. Okay, we'll come to that. Okay. Now in pseudocode, just to make it easier to read, we'll use capital letters for not and or. In Python, we've already seen it's all lowercase. Makes no difference. In C++, these are used. 2 vertical bars for or, 2 ampersands, exclamation for not. We'll try not to use these, but occasionally we might. They will not work in Python. They may work in Visual Logic, some of them. Don't worry about Visual Logic so far. We won't have much need for any of these. Okay? Even and or not. But anyway, not has the highest priority because it's unary. Then arbitrarily we are choosing and then or. In different languages, these two could be switched. These two rows could be switched. So you have to watch out. If you're taking Java or something, C++, you have to watch out. because languages evolved from 1950s onwards, higher level languages. So they keep changing their minds occasionally and they have different rules, etc. If you're confused, use parentheses. That will usually straighten things out, at least for somebody who's reading the program. Okay, this is very important. Truth tables, you got to memorize them. This is the simplest one. If I have a variable called input, not of input, this expression evaluates to the opposite in meaning, right? That's the simplest. We've seen that already. I'll try and build these two tables briefly, but let's discuss each one. Suppose we have PQ instead of input. Capital, they should be variables, lowercase. If both are true, P and Q is true. But in all other cases, if any one of them is false, this is defined to be false. This is a definition. There's nothing to discuss, no arguments or anything. We could have defined differently, but Boolean algebra and logic has been around for 150 years, and that's the table they've decided upon. Okay. Similarly, OR, sometimes called inclusive OR, if any one of them is true, this turns out to be true. It's false only when both of these are false. So let's test some of these out and try and write little programs for that, unless we already have them under samples. I don't think I have them, so let me start a new window. First, let's see if I can do one little thing in the shell, and that is there's something called range. Let's see if it evaluates that. No, it doesn't evaluate it. But if I write a little program to print out for I in range, wait a minute, I may have to use square brackets. I've forgotten already. Let's try that one more time. Range. Because when you know a lot of languages, you get confused between them. No, that doesn't work. Okay. For x in true, comma, false. This is a list which has two values, okay? So x will first be true, and then later on it will be false, okay? You'll run through this loop 2 times. And we'll look at for statements in much more detail later on, but for now, let's see if it works. I'm not even sure if it works. Again, true, comma, false. You have to end each for statement with a colon, okay? And then I'm going to write a very simple program to print out x or y. That's all. That's the complete program. So it should assign the value true to x, true to y, and do this statement. Then it does the inside loop first, not the outside loop. So y should be assigned false, and then you print x or y. And then x will change to false, y will restart with true, and then take on the value false later, and then print this. But let me also print x as well as y. I'm doing something slightly more advanced. Instead of writing 4 separate print statements and many assignment statements, let's save this as OR. Okay, we'll call it OR dot py. Okay, so that's the output. See, x was true, y was true, x or y is true. Then x is still true because we are doing the inside loop first. Y is false, x or y is true, right? According to that OR table. And the only time it's false is when both of them are false. Where is it? I lost track of that. It's hidden away somewhere. Here it is. Okay. So do you have any questions on this? This program is not going to be on test 1. On test 2, we'll be more concerned about for loops and if statements, okay? I just want to show you how to make the truth table. Similarly, if I change this to an AND, you should get true, false, 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 okay? Let's go back to this. So I just showed you how to make this table, not this one. But on a test, on any homework, if I ask you to evaluate an expression like this, now again we are discussing pseudocode and everything on paper, so I'm using capital A and D for it to stand out. So of course in Python you'll write lowercase. So since we have two ANDs, these are done left to right. And true and false is false. False and true is again false. So this is the final result. If on a test I write a print, parentheses, etc., and Python expression, you should be able to figure it out. We just want true or false value, right, for an expression like this. Again, there are a lot of exercises at the end of the chapter. Please read the chapter carefully. People usually make more mistakes in this chapter than anything else on the test. Okay. So this also, I'll skip over that, go on to a more complicated one. Now we have parentheses for the first time, so of course you're going to do the parentheses first, and this evaluates to true. Then between and not has higher priority, right? It's unary. The results may be different if you ended up doing, if you put parentheses around this and this, okay? So not true is false, false and true is false. Any questions on this? So just like arithmetic expressions, I want to see this chart if I give you a complicated thing to evaluate, because I may give you partial credit for doing it partly right. Okay? If you just come up with the wrong answer, true, I'll have to give you 0 or 1, right? I mean full credit or no credit. If you show me the work, I may give you partial credit. Okay. Now, of course, these are meant to be used along with the other operators, arithmetic and relational operators. So again, we said all arithmetic comes first in an expression like this. So this is done first. Then relational operators come before the logical operators. So this is done next. And finally, you can combine these two and you get that answer. Do you have any questions on this? Okay, this is a very simple example, and in 135, CSC 135, etc., you'll have plenty of such examples and more practice, of course. But this is a place to learn it. 120 is the place we introduce all this. I'll skip over this, but this percent sign, if you remember, 16%5 gives you a 1, right, remainder. So you can expect something like that on the tests. Assignment operator, very simple. We have some simple rules. Again, these are conventions for pseudocode and for Python and for Visual Logic. For variables, use a lowercase letter as the first letter in a name of a variable. But you can use numbers also, 0 through 9. Cannot use spaces because that causes confusion. Or any other non-alpha numeric letters. Non-alpha numeric means not an alphabet, not a number. But we allow underscore. It doesn't say anywhere here or perhaps in the book, but underscore is allowed. So these are some examples. Pay rate is fine. It's called the camel notation as a reminder. This is invalid because the space over here. This valid for a variable or an identifier. It's also called an identifier. This is not valid because of the number. Special characters not allowed. Because if we did, then how about a plus or a slash or a minus? That will cause confusion, right? This is not allowed because this dash can be confused with a minus. This is allowed. Now, there may be an error in the book. I think it says it's not allowed but that's something you can overlook. We hardly use this because we have the camel notation, so we don't use this. Except for constants, right? If these are all capitals, car color, for example, is assigned a constant value red or something, then it's okay to use an underscore like this. So this is very simple, nothing special. I don't think I'll ask you such questions on the test. But use the camel notation throughout the course for all your assignments. It makes it much easier to read your programs. And don't use X, Y, Z as variables. These H for hours, why not use hours? Or hours worked. Or beginning hours, or something like that, more meaningful. Okay, coming to the not equal and equal, again these are pseudocode, but this also works in Python. I believe not equal works in Python also. So this is an example. It also works with Booleans, but then you should have Boolean both places. Is true equal to false? No. So the answer is false. Is 5 not equal to 5? That's also false, because 5 is equal to 5. Anyway, I don't think you have any questions on this slide, right? Do you? Finally, this table is very important. You have to just memorize it. And it's simple also. Above this line are the arithmetic operations. And you're already familiar with these. Then come the relational operations. These have higher priority than these two. And they're done left to right, except the not has to be done right to left because it's unary. Okay? And the order between these three is not higher than and, higher than or. Finally comes the assignment statement. I mean, you evaluate the right side of the expression assignment statement first and then assign something to the variable. Of course, you got to use just a variable on the left side. So you get used to this table by trying out problems from the back of this chapter, okay? So there's not a whole lot in the conclusion. We've looked at 6 new relational operators and 2 constants, Boolean constants, and expression, Boolean expression. So there's a little bit more information in this chapter than the other older chapters, but it's included on test 1. And please note, logical operators and or not can be used only for Boolean values or variables, Boolean constants or variables, okay, as defined by the truth table. And you must use a variable on the left side of an assignment statement. These are all obvious by this time, hopefully. Let's go on to assignment 3. And I'll just start that with, I think on this it says, look at sample 2 on the y drive to understand the find command. So let's just start that. Sample 2. You can also look at these two. Let me start this one and then we'll see what the other two are about. Okay, if I assign this value to this variable, it has a period in it. So this says within this variable, find the position of period and tell me where it is. Give me a number By the way, the string starts counting from 0. So j is at position 0, this at position 1, 2, 3, 4, etc. So I'm just printing out that number where the location is. Then I'm extracting from position 0 to 1 less than pos. Okay, if pos is telling me this number, then the first name is to the left of that, right? And this says to the right of pos, everything beyond, so I don't have to mention the end of the string. And then print out the first name and last name. So this is a very simple demonstration of find, but it gets confusing sometimes. Okay, let's run it and then see if you have any questions. Okay, position has the value 9. So this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? That's how they decided to do it. In some languages, they start counting with 1. Okay? It all depends on the language. Java may be different. C++ may be different. Now, this notation is called the object notation. This is considered an object. All variables are considered objects. So you can say name of the object, which is name, dot find, use an operator or built-in function. It's called a built-in function. And you might see this a little bit in this course, but more often in Java, in 135, etc. But do you have any questions? Then pulling out the first name gives you Jonathan without the period, and the last name Smith without the period again. Because please note I have used pos plus 1 here, and pos over here means 1 less than the value of pos. So this 9, therefore 0 to 8 is what I'm going to pull out. Okay, any questions on that? All right, let's see what's in sample 1 and sample 3. I don't know if there's anything useful there, but I've forgotten what's in there. Probably nothing very different or useful. Oh, this just shows you concatenation. So if you input a string, I'm not converting it to an integer or float, right? So what I read in is a string. It'll print out that string combined with hello. So there's nothing much in that. Let's try the other one. It keeps going back to this. Course information or code samples. Sample 3. Okay, here we are allowed to read in a string. Okay. Hopefully that has a colon in it, right? Because that's what we are looking for. If we don't find it, pos will be -1. It won't be 0 because 0 will mislead you, right? So we'll try it out 3 different times. Now here we are printing out a fixed part of the string. What are we printing out? Just one letter, right? Starting from 2 but less than 3, so that's one letter. And within that we are finding this again. So things can be tricky over here. Let's run it. Enter string. Okay. 1, 2, 3, 4, colon, 5, 6, 7, 8, 9. Okay, what do we have? Position of colon equals 4. So this 0, 1, 2, 3, and the position is 4, isn't it? And it's going to print out starting from 2. So 0, 1, 2. That's 3. And 1 less than 3. 1 less than this number. And find the colon. Well, we've not changed the string. The point was just picking out something from the middle of a string doesn't change it. That was the point. So it's still 4, right? If I had looked for, say I assigned string 2:3 to some other character, C or something, and then C dot find, I look for a colon again, it will not find it. But if I had 2 colons, now how does this help? Because let's go back to this assignment now. You're going to prompt, this is the prompt, starting weight of food for a monkey is equal to, you enter this exactly, 8:9, okay? That's run 1. And then ending weight equals 6:40. So the colon can be anywhere in the string, because that's in pounds and this in ounces. Okay? So finally you've got to figure out the total food consumed is 1:11. Consumed equals 6. So how do you get this from that, from these two? 8 times 16 plus 9 ounces. Convert everything to ounces. Just like you had that programming problem where you had hours and minutes and you convert everything to minutes. This time you're reading in one string, extracting the 8, extracting the 9, converting both to integers, then figuring out this. Similarly, do this. Same idea. I'm going to say something here. And then you subtract the 2, right? And the x minus y that you get, you got to convert back to pounds and ounces. So this is sufficiently complicated for you to write pseudocode for people to understand what you're doing. Now please note, pseudocode should be without Python notation. You have to assume that we are not talking about Python here, okay? So I'll give you 2 lines maybe of the pseudocode. You could always have a comment explaining what the purpose of this pseudocode is, and then say start weight or get start weight. Do you remember the get statement? Okay. And you could always write a comment saying start weight is pounds colon ounces. And then you could say position of the colon or whatever is find colon in start weight. So that gives you English-like notation, right, for the pseudocode. And I'm not going to go beyond that. You've got to be creative, little imaginative, and keep it free of Python. Because somebody who's reading the pseudocode may want to use it for Java or Fortran or whatever language, okay? Visual Logic, anything else. I don't think this problem can be done in Visual Logic because it may not have the find command or something which processes strings conveniently. That's why I've asked you to do it only in Python and give me the corresponding pseudocode. Now, how would you start doing this problem? Just focus on the first input, the starting food value, nothing else. Write the pseudocode, write the program, test it out. If everything works, then write the next 3-4 lines of the pseudocode and write the next 3-4 lines of Python. And finally, last 3-4 lines of pseudocode and Python and end. Okay? So this is only about 8 to 10 lines long, not much more than that. But you have to do it carefully and you have to test it on both runs, okay? Or additional runs, at least 2 of these. Any questions on the assignment? Yes?
For student code, are we allowed to use standard operators like plus, minus, multiplication?
After you convert to integers, they work the same.
Oh, no, I mean, you said don't use Python syntax in pseudocode.
Oh no,
Because some
that's allowed in pseudocode too.
No, I mean, like some languages with integer division, major division.
So if I want to avoid writing // for integer division, what do? In Python, I could say, in pseudocode, in Python, it might be x / 60 or something, right? In pseudocode, I'll say, or let's say z gets that for the time, z equals that. That's the statement I'd like to write in pseudocode. Z gets integer division of, or integer divide x by 60. I can use English, right? It may be a bit ambiguous sometimes, but anything that's clear enough should be okay. Does that answer your question? Okay. Why should I avoid using Python-like notation? Now, for homework 1, I did not worry about it because I hadn't told you that, right? And then, of course, similarly, you use % here. But in Visual Logic, it's mod, spaces before and after, and what was that? A backslash. So Visual Logic's different. Now, in pseudocode, I get to write in English. So I would write remainder obtained after dividing x by 60. Okay, something like that. In English, you can write anything, right? It's a very powerful natural language. So please do not confuse pseudocode with Python, Visual Logic, etc. And it comes first. Or you can make a flowchart. But again, in flowchart, what do you write in a box? You got to write some explanation in English. Unless you're working with Visual Logic, then you're allowed to use the syntax of Visual Logic, etc. So do the best you can, and it's not a difficult assignment. It's very simple. Some of you will probably do it in 20 minutes or less. Some of you might take longer, but try and do it independently also. You learn a little bit more. Plus, that sample 2 program is for that purpose, to help you out a little bit. If I didn't tell you about find, etc., it's very difficult to figure out how do you get one character at a time from a string, or how do you find a particular character. That's why you may not be able to do this assignment in Visual Logic. You can try. You might succeed. I have not read the complete documentation of Visual Logic to see if there are string processing functions in it. I'm going to stop here. If you have any questions, please ask. Thursday will be a lab day. I don't plan to lecture.